Systems of linear equations. In a plane, two lines intersect unless they're parallel. Two distinct lines that intersect have different slopes. Parallel lines have the same slope. Perpendicular lines have slopes whose product is -1. Given two distinct lines, where line 1 is m1x plus b1 and L2 is m2x plus b2, intersecting lines. L1 and L2 intersect if the slopes are different, if m1 does not equal m2. Parallel lines. L1 and L2 are parallel if m1 equals m2. They have the same slope. Perpendicular lines. L1 and L2 are perpendicular if m1 times m2 equals -1. Exercise A. If f of x equals 2x minus k, and that line intersects g of x equals k minus x at x equals 4, what is k? All right, so what we know is that f of 4 equals g of 4, since both lines at 4 have the same y value. So we can figure these out, set them equal to each other. So that means 2 times 4 minus k, which is f of 4, equals g of 4, which is k minus 4. So that's 8 minus k equals k minus 4. We will subtract k from both sides and subtract 8 from both sides. So that gives us -2k equals -12. K equals 6. So here's the solution. K equals 6. If you were to plug 4 for x and 6 for k into one of those equations, we would have 2 times 4 minus 6, which is k, and that would equal 8 minus 6, which is 2. So the y coordinate would be at 2. X is 4, y is 2, and that's where both of these lines intersect, right at that point. Exercise B. Are the lines L of x plus 3 equals -5 times x plus 1 and 5x plus y equals 15 parallel? This line here is already in point slope form, so that is y minus y1 equals m times x minus x1. Therefore, m is -5. That's the slope of this line. The second line we can rewrite into slope-intercept form. Y equals -5x plus 15, and in slope-intercept form, that's y equals mx plus b. Therefore, m is -5. M is -5 in both lines, therefore they are parallel. And here is a graph that shows the parallel lines. Exercise C. If kx plus y equals 3 and y equals -0.5x minus 2 are perpendicular, what is k? All right, so let's put this into slope-intercept form. Y equals -kx plus 3. And here we have, or that's already in slope-intercept form, the slope here is -0.5. So we know that -0.5 times -k is going to equal -1, since that means that they are perpendicular. So that would be 0.5k equals -1. Divide both sides by 0.5 and we get k is -2. K is -2, and we see here in the graph that these two lines are perpendicular. A system of equations is a collection of two or more equations with the same unknown variables. In this section, we will focus our attention on linear systems of two equations and two unknowns. In solving a system of this type, we try to find all paired values, x and y, that satisfy the two equations. Given ax plus by equals c, and dx plus ey equals f, what is the difference between the capital and lowercase letters in the system above? What is the solution of a system of equations? In the case of a linear system of two equations and two unknowns, what are the possible outcomes? What is the difference between the capital and lowercase letters in the system above? The capital letters represent coefficients or constants. The lowercase letters are variables. What is the solution of a system of equations? A solution is all pairs x sub n, y sub n that satisfy the two equations. In the case of a linear system of two equations and two unknowns, what are the possible outcomes? The lines can be parallel, no solution. They can intersect and have one solution, or they're the same line with infinite solutions. Here are graphs of the three possible outcomes: parallel lines where there are no solutions, an intersection where there is one solution, and they are the same line, therefore there are infinite solutions. Solving systems using technology is simple. In Desmos, graph two equations, and a click at the points of intersection will reveal the solutions. Solve y equals 2x plus 4 and y equals negative 3x minus 1. Alright, so using Desmos, you can graph both of these lines, and then you click at the intersection and it will tell you the solution, negative 1, 2. Carefully sketch the graphs by hand and use as an aid in finding the solution. Alright, so we have x minus 2y equals 6 and y equals negative 3x plus 11. So first thing I'm going to do is change this into slope-intercept form. That gives us negative 2y equals negative x plus 6. We'll divide everything by negative 2. And that gives us y equals 1/2 x minus 3. So let's first graph this line. Our y-intercept is at 11. And then we have a slope of negative 3. So we go 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. So let's connect all those dots with a line, just like that. All right, and now let's graph the other line. Y equals 1/2 x minus 3. So we have our point at negative 3, and then we have a slope of 1/2. So we go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So we can connect those as well. And we have our solution right here, where they intersect at 4, negative 1. And there we go, the solution, 4, negative 1. Solve the system using substitution. Find the exact value of each coordinate. So if line 1 is 2x plus y equals 9, and y equals 4x minus 9.6, the intersection is somewhere here. When finding the exact solution, sketching the graph is not enough. The graph, though, is a great way to check your solution. Alright, so we know that y equals 4x minus 9.6 and 2x plus y equals 9. So we can take this value for y and plug it into the other equation for y. So we get 2x plus 4x minus 9.6 equals 9. We can solve that for x. We get x equals 3.1. Then we plug that value for x back into the original equation, and we solve for y. Y equals 2.8. So our point is 3.1, 2.8. This is our exact solution. Solve the system of equations using the elimination method. 3x plus 8y equals 81. 5x minus 6y equals negative 39. Alright, so our goal here is to eliminate x. We have 3x and 5x. So the lowest common multiple of these is 15. So if we make the top x into positive 15 and the bottom x into negative 15, they'll cancel in the next step. So let's multiply the entire first equation by 5 and the entire second equation by negative 3. Once we've multiplied the first equation by 5, we get 15x plus 40y equals 405. And once we multiply the entire bottom equation by negative 3, we get negative 15x plus 18y equals 117. Then we just need to add them together. So we'll add this equation to this equation. These cancel out. Those add up to 58y. Those add up to 522. We divide both sides by 58, and we find that y equals 9. We know that y equals 9, so we can take one of the equations, write it out here, and plug 9 in for y, and solve for x. X equals 3. Solve for x comma y in terms of k. Line 1 is 2x minus 3y equals 9k. Line 2 is 4x plus 5y equals 7k. We want the x's to cancel out. So the easiest way to do that is to just multiply the top equation by negative 2. Once we do that, the top equation becomes negative 4x plus 6y equals negative 18k. Then we can add the two equations together, and that gives us 11y equals negative 11k, y equals negative k. Once we have our value for y, we can take that value and plug it in to the second equation. So we have 4x plus 5 times negative k equals 7k. Solve for x, and we get x equals 3k. Therefore, our solution is 3k, comma, negative k. Systems can be used to model real-life scenarios with two unknown values. Sometimes it's necessary to create our own equations based on the given information. Tip: assign variables to unknown quantities and remember that you need two equations in order to solve for two unknown quantities. Altogether, 292 tickets were sold for a basketball game. An adult ticket cost $3. A student ticket cost $1. Ticket sales were $470. Determine the number of adult and student tickets sold at the basketball game. If we let A stand for adult tickets and S stand for student tickets, we know that the number of adult tickets plus the number of student tickets equals 292 tickets total. Now if we do an equation for the prices, 3 times the amount of adult tickets sold plus 1 times the amount of student tickets sold equals $470. So we have our two equations here. So we can then solve the system of equations. So we're going to multiply the top here by negative 1, and that gives us negative a minus s equals negative 292. We'll keep the second equation as is. The s's will cancel. That will give us 2a equals 178. Therefore, a equals 89 adult tickets sold, and then we can plug that value in to the equation, and we get that s equals 203 student tickets sold.